Okay, so the last lesson in this mini-unit is on solving one-step equations with decimals. This would be an example of an equation where we're going to use one transformation to solve, and obviously it has decimals. So we'll use a transformation. We're going to estimate a solution. Actually, we're going to do that first, and then we're going to check our solution as always. So this would just be an example, and we'll do that problem on the next page. So when I have this equation, n minus 2.75 equals 8.3, the first thing I'm going to do is I'm going to estimate the solution. So let me erase, get my pen right. So I'm going to estimate. Now I'm going to change the n minus 2.75 to n minus 3. I'm going to leave 8.3 at 8. I'm going to add 3 to both sides, and I'll get that n equals 11. So my estimate is that n needs to equal something in the neighborhood of 11. All right, so back to the real problem though. So I have n minus 2.75. I want to get n by itself. Right now it has 2.75 subtracted from it, so what I'll have to do in order to get n by itself is add back 2.75. So I'm going to add back 2.75. That's my transformation. I've got to do that to both sides. I'll add a 0 to that 8.3, and then I will get n equals 11.05, and that certainly looks like it matches well with our estimate. Now then I'm going to do an equation check to make sure it worked, and I'm going to say 11.05 minus 2.75. Does that equal 8.3? If I need to do a little work on the side over here, I can verify that. Five minus 5 is 0, and I'll have 10 minus 7 is 3, and 10 minus 2 is 8, and I borrowed there as well, so I get 8.3, so 8.3 equals 8.3, so the equation checks, and I circle my solution. I found the value for n that makes that original equation true. Let's go to the next page. So in this next one I have a plus 32.66 equals 42. So let's again estimate. So I'm going to make the 32, I'll go ahead and round that up to 37. So I have a plus 37 equals 42. So to get a by itself, I'm going to subtract 37, and I have an estimate of 5. That's what I'm hoping my solution will be close to. So in the original problem, I'm going to subtract 32.66 from both sides. To add a couple of zeros here and a decimal place with the 42. I've got 10 minus 6 is 4. I've got 9 minus 6 is 3. I've got 11 minus 2 is 9. And so I got 9 point. So this is a case, actually, as I'm getting my solution here, it looks like I've made a mistake in my estimate, so that happens. So let me go back and change this. I'm just going to put a line through that. So my estimate is actually flawed. I needed to really say a plus 33. I'm not sure I got 37 equals 42. So I'm going to subtract 33, and I will get that a should have actually equaled 9. That should have been my estimate. Sometimes your actual answer makes you question your estimate, so that can happen. So that just happened to me. So, but I'm liking my solution of 9.34. I'm going to check it now. and I've got 9.34 plus 32.66. I want to know, does that equal 42? I can do a little work wherever I can find room. I'll add 9.34 and 32.66, and I'll get 0 and 1 is 0 and 1 is 12 and 1 is 42. So that works. So I get 42 equals 42. That checks, so that is a good solution. Now, next problem, a little different. I've got x divided by 4.8 equals 5.4. Let's again do an estimate. Hopefully I'll do it right this time. So I've got x divided by 5, and I'll go ahead and say that equals 5. And so what I'd have to do if I have division by 5 would be to multiply by 5. So I would multiply by 5 to undo the division of x by 5, and so I get an estimate here of x equals 25. Now, doing the actual problem itself, I'm going to say I'll rewrite it as x over 4.8. So x is currently being divided by 4.8. And I want to make sure I undo that division, so I'll multiply both sides by 4.8. And when I multiply 5.4 times 4.8, I'm going to get I'm going to get 25.92. And that certainly looks close to our estimate of 25. But I'm still going to check it. I'll say 25.92 divided by 4.8. Does that equal 5.4? Well, I'll need a little more room to check that out. So I'll go ahead and do that division over here. I'll say 2259.2 divided by 48. Let's see if that comes out at 5.4. Let's just go ahead and assume that it does. 5 times 8 is 0, and 4 to 20 is 24. I've got 9, 1, 2, and let's 4 times 48 is 2, and 3 to 16 is 19, so that checks up at 0. So this indeed does come out at 5.4 equals 5.4, so that checks. And a line here, divide out the work, and so this solution is a good one. Next example, I've got 9 equals 3.6d, and so if I want d by itself, I've got to undo the multiplication by 3.6. I'm going to want you to use a reciprocal there. So let's again first do an estimate. So over here I'll say 9 equals, that's my estimate, equals, I'll round up 3.6 to 4. And then I'm going to multiply both sides by 1/4. And I'll get that 2 1/4 equals D. So that's my estimate, something around 2.25. Now, so let's do the real problem. So I've got 9 equals 3.6D. I'm going to want to multiply by the reciprocal of that, so I'll multiply by 1 over 3.6. So that's going to mean I'm dividing 3.6 into 9. I can do that over here. So 9, it's going to end up being 90 divided. Okay, for some reason it didn't, I'm not sure if this last page recorded, so if this is a repeat, you can stop listening. But we had a board game in which each box stood 2.5 inches high and had to be placed on a shelf 15 inches high. How many boxes would fit on the shelf? Well, I'm going to let X equal how many boxes that would fit on the shelf, because each one of these is 2.5 inches high. The total shelf is 15 inches, so we want to say 2.5 inches times how many boxes we have would equal 15 inches. So what I did there was multiplied by 1.25, 1 over 2.5 on each side, so I get X by itself, and I got 6 boxes.